Good morning to everyone. Today's my topic is on encoders and decoders. First of all, we want to know what is meant by encoders and decoders. Encoders and decoders are the most important circuit, that is combinational logic circuit used in a digital electronics. We can say it is as a backbone of a digital electronics in a combinational circuit. The encoder converts, first we want to know what is meant by encoder. Encoder converts input informations, that is in a one format, into a coded output, that is in a coded output, whereas decoder performs the opposite function of an encoder, that is it convert coded data back to its original form. Both are widely used in a communication systems, computers, automation and control circuits. There are many examples for encoders and decoders. First, let's move on to encoders deeply. First, what is meant by encoder means we already say that encoder is nothing but it just is a convert information from one format to another format. That is, if an encoder is a circuit that converts 2 to the power of n input lines to a n output lines. That is, it produces a binary code that represents which input is active. It's only produce the output which inputs are active in a phase. It's mainly used in digital systems for data handling, etc. Mainly encoders reduces number of data lines because it's only gives the output where the input is active in a time. That is, it reduces the number of data lines. There are many examples for encoders like priority encoder, binary encoder, octal encoder, so on so on. Let's first of all, what is we move on working principles or basic functions of encoders. Here encoder, that is it's the input will be in a multiple lines and convert it into a coded binary output. That is, only one input should be active at a time. The encoder reads the active input line. That is, we can say the output represents the active input in a binary form. It generates binary output only in a processor. This output is used for efficient digital processing, communications. Like we can say in a keyboard sensors, we are using a encoder. Next, this is a block diagram of an encoder. See, where we say that it will convert 2 to the power of n input lines to a n output lines. This is a basic block diagram of an encoder. Next, the types of encoder. If we see the types of encoder, there are many types. In that, there is a binary encoder, priority encoder, decimal to BCD encoder, octal to binary encoder, mechanical or optical encoder. Whereas in the binary encoder, it converts 2 to the power of n input lines into a n bit of binary output. For example, we can say binary encoder, there is maybe 4 to 2 encoder, etc. 8 to 4 encoder, we can so go on. It is mainly used in keyboards, sensors, digital circuits to compress the data. Mainly encoder is to compress data because we know there is a 2 to the power of n input lines into a n output. That output is a compressed form of input. So it's mainly used in a data compression. That's why we are using the wires are less in this, connections are reduced in a binary, normally in a encoder. Whereas a priority encoder means the name priority, it's denotes that it gives the highest order input. That is, it gives the priority for the input lines. Whereas it works when multiple inputs are active at a time. Gives priority to the highest order input. Okay, that is gives the highest order priority for the highest order input. It's mainly commonly used in interrupt handling systems of microprocessors. Mainly priority encoder is used in a microprocessors. And also we can say many interrupt systems, etc. The main priority encoder we say means 8 to 3 priority encoder is most used. Then if we go on to octal to binary encoder, it's the octal means we know already that's 8 input lines. Here 8 input lines is converted into a 3 binary output. It's mainly used in digital circuits that process octal data. For example, if there is an input is 1, the output will be a 0, 1, 1. It is also mainly used in microprocessor interfacing and etc. It's mainly used for representing the data, representing the octal data into a binary format. Then decimal to BCD encoder is nothing but decimal we already know 0 to 9. It's converted into binary coded data. That is, the output will be in a binary coded data. Here mainly used in a calculators, digital displays, counters, we can say 7 segment displays it's used in a decimal to BCD encoder. It helps systems display numeric values easily. It's mainly used to display the numeric values very easily. And let's go on to mechanical and optical encoder means it is mainly used in a motion control and robotics. That is, it is used to convert physical movements, mainly physical movement into a digital signals. There is a mechanical operations mainly done upon a physical movement. It is that converted into a digital signals. Whereas in mechanical encoder, it detects rotations. Mainly is used to detect the rotations using switches. Whereas in optical encoders, it uses light sensor and a coded wheel to mainly discuss etc. There is a optical encoders. Right? It's mainly the applications of mechanical and optical encoders is used in robotics, automations, motor control, CNC machines etc. We can see more than that also. Then main applications of encoder we go up means it's mainly like we discussed earlier. It's used in microprocessors and robotics and motion sensing. Its main importance is the encoders the data compression and also the interfacing process in microprocessor, feedback signals, position controls in robotics etc. so on so on. That's it of encoder. Let's move off on decoders. What does mean by decoder? Is nothing but same. The decoder is the just opposite reverse process of an encoder. That is it converts the coded data into original format. That is, it converts the n input lines into 2 to the power of n output lines. It activates only one output for each input combinations. It's also used for display controls, signals and etc. Combination circuits, so on so on. That's a main working principle or we say for the basic functions of decoder means it accepts binary inputs and or BCD inputs. Binary or BCD inputs we can say that's all. It activates a specific output that matches the input code. That is, it accepts binary inputs and activates one specific output lines. It is also used in a selection, display, memory addressing applications, so on so. Mainly used in a demultiplexing applications, whereas encoder is used in a interfacing process. Here is a decoder is mainly used in a demultiplexing applications. It helps to select specific memory locations, and it's also used in addressing process in a microprocessor. There are many examples we can say for decoder 2 to 4, 3 to 8 etc. The types of decoders means there is also binary to decimal decoder, BCD to 7 segment decoder, demultiplexer as decoder, n to 2 to the power of n decoder, address decoder. Whereas binary to decimal decoder is nothing but it converts binary input to one of the several decimal outputs. Example used in digital clocks and calculators. Whereas in calculators we are giving a binary inputs, it is used for a decimal output. And then BCD to 7 segment decoder is what means it converts the BCD 4-bit BCD to 7 individual segment signals. That is, convert binary coded inputs into signals to drive display segments. Mainly used in digital clocks, calculators, and output control. It's also used in LED, LCD displays, etc. And it mainly used for a 7 segment LED LCD displays. Main common ICs used in BCD to 7 segment decoder means 7447. Then demultiplexer as a decoder means Mainly it's a demux that can act as a decoder by routing one input to a multiple outputs. That is the decoder will decodes the input to a multiple outputs. That is the demux can act as also decoder. The main applications of decoder means we are going for a demultiplexer. No, that's that. Used for data distribution and signal routing. Then if next type is to n to the 2 to the power of n line decoder means is main very common type, that is 2 to 4 decoder, 3 to 4 decoder, 3 to 8 decoder. It's under the n to 2 to the power of n line decoder. It's mainly used in address decoding, memory selections, etc. Whereas in address decoder means mainly address decoder is mainly used in a microprocessor and memory circuits. It selects specific memory locations based on input address bits. Whereas the main examples for decoders is 2 to the power of 4 decoders, 3 to 8 decoders. 2 to the power of 2 to 4 decoders, there is 2 input bits, 4 output lines. Each output corresponds to a unique input combinations. Often include an enable pin for control. Enable pin will be used to control the outputs. Whereas 3 to 8 decoder means there will be 3 input bits, 8 output lines. Widely used in RAM, ROM, address decoding, etc. It helps to expand control signals in microprocessor systems. Mainly decoder is used for expanding the, whereas the encoder is used for compression, decoder is used for expanding. Main applications of decoder means is used in a microprocessor. As we decoder and encoder mostly is used in microprocessor, addressing, etc. And mainly display systems for driving 7-segment displays, and also for data signals, that means demultiplexing data signals, and control and automations, and digital clocks, counters, so on, so we can say for decoder applications. The main comparison of encoder and decoder means, whereas main comparison for encoder means encoder is used for a data compression, whereas decoder is used for a data selection. That is the main comparison for the encoder and decoder. The encoder converts data into code format, whereas decoder converts the coder into back to the original form. That is decoder expands signals, whereas encoder compress the signals. That is mostly both are used in complementary in digital circuits. Mainly both encoder and decoder is most important in a combination, that is digital circuits. In nowadays, so on, we are using everywhere where the encoder and the decoder. Normally in day-to-day life, we can say many examples like keyboard uses encoders to generate key codes, whereas in robotics uses rotary encoder for feedbacks. In communication systems and driver displays for the, in a bus center we can see the digits displaying the shows the routes of the area. That is also used as an encoder decoder. That is everywhere there is using a digital signals, digital systems, where the encoder and decoder plays a main vital role in day-to-day life. From this we can conclude that encoder and decoders are very important in digital systems. They help in a data conversion and control, mainly used in both everywhere, that is automation, computing, communication, in day-to-day life, everywhere we are using. We can understand both the circuit designs easily, because there is no difficult in encoder and decoder. Mainly we can say encoder and decoder is the main fundamental building blocks in our EC department. We can say that is. Thank you.